temperature now to get a fuller understanding. We know now that the temperature is how quickly the particles are moving, and we can look at and we can measure temperature now rather than in degrees centigrade. We can measure it in Kelvin, which is the absolute temperature scale. So absolute zero is 0 Kelvin, and in degrees centigrade it's minus 273 degrees centigrade. Let's just write that down up here to remind ourselves. So 0 Kelvin. In fact, let's write down absolute zero is 0 Kelvin, and that's also equal to negative 273 degrees centigrade. Okay, so what does that mean if we looked at all these different particles moving around? And what we're going to do is we're going to imagine that we're looking at all these particles and we're measuring the speed of each of the particles. Unfortunately, I can't actually pause this simulation, but if I could, I would like to point at one of these atoms. So we're going to imagine that I'm pointing at one of these particles. In fact, I could draw one, couldn't I? I'm going to draw this particle, and I'm going to say just particle. Let's say particle 1. And what we're going to do is I want to imagine let's imagine what the speed is. So let's put the velocity is, I don't know. In fact, I'm not going to put velocity because it's not quite the same as velocity. I'm going to say speed. And well, let's just write speed is 10. I'm not going to mention the units because we're not going to worry about the units. We're just going to imagine it's just 10 or 5 or whatever it might be. So, and down here we have the speeds down here. So maybe how many particles are moving at one speed of 1 or speed of 2 or 3 or 4 or 5 and so on. And it looks like actually it's changing, right? So this is how many particles are moving at that speed. And over here, this is how many particles are moving at that speed, and so on. Now, and this is for a relatively warmer substance, and you can see that these speeds are changing. So why do you think the speeds of the particles might be changing? Or why? First of all, okay, let me just write the two questions down, and we can think about how we can answer these. Question one is, why are there a range of different speeds? And I'll leave a gap so we can write the answer in. Question 2, why are the speeds changing? Okay, so let's just have a think about why the reasons for that. So there are a range of speeds because the particles are constantly bumping into each other and transferring energy from one to another. If you were to pick one of these particles and watch it, I just noticed one there. This one here is now moving quite quickly. Then it slowed down. It slowed down because it bumped into another particle, and the collision caused the particle to actually slow down. But then a short time later, maybe another particle hit it in such a way that will cause it to speed up. And so the range of the speeds of each individual particle slow down because of it constantly colliding with other particles. And we know that the speed is related to the kinetic energy. So before, when I said that that the temperature is a measure of speed, it's probably more accurate to say the temperature is a measure of kinetic energy. And we looked at energy on a previous lesson, so we can just remind ourselves that kinetic energy is equal to the half times the mass times the velocity squared. So we can say that the kinetic energy is directly proportional to the velocity squared, and that would actually mean that the temperature would probably be also directly proportional to the velocity squared, or the speed squared. Now, I'm not going to explain the reasons why. No, actually, that's fine. Let's just say for now that v is equal to speed. Don't think about it as velocity. because we're not so interested in direction. So the reason why they're constantly changing is because of these collisions and the transfer of energy from one place to another. Okay, and you'll notice that how does it change? Well, first of all, the sum of the kinetic energy, so the total kinetic energy remains remains constant while the temperature is constant. Okay, while temperature is constant. If we allow energy to escape, then the kinetic energy is going to reduce, and the temperature is going to reduce. But while the temperature is the same, even though the kinetic energy of individual particles are changing, the total kinetic energy is going to be constant. The other thing that we notice is that for hotter temperatures, they have a higher maximum energy. I mean, it's fluctuating quite a bit, but this is sort of average. Okay, so this is higher, and also if we look at where the temperature, the maximum is, it's over there. Whereas for the colder one, it's over here. Oh, that's not quite right. It's around here, isn't it? So the colder temperature. For colder temperatures, we have a lower maximum, a larger spread, and the maximum is at lower. Hang on a second. So this is. I wonder if the speed of the particle going from left to right. So this, I think this must be a little bit more confusing. Have I got this wrong way around? Oh, I've got this wrong way around. It's because that's blue and that's red. But the blue ones, I've got this wrong way around. Because if you have a look, the blue particles definitely look faster than the red particles, don't they? But so yeah. So I just assumed the blue was colder, but no, it's the other way around. I don't know why they use those colours. That's just very confusing. Everybody knows red normally means hot. So this is colder. Everything I've said is still fine, but yeah, I'll explain that. I'll explain the difference. I'll just use red again. Hotter. I don't know why they choose those colours. So so when it's colder, there's a less of a spread. Let's just let's write these key points here. A smaller range of speeds, and also there is the maximum. Let's say the maximum speed is lower. That's no surprise if it's colder. And yeah, that's it really. And then hotter, we have a larger range of speeds, and the maximum speed is higher. Okay, happy with that? Okay, so let's stop that, and we'll save that video too.